What's going on YouTube? It's Joe Rivera back again with another video, and it's been a couple of months since I've done a video like this, and it's time to do another one. I enjoy doing this, and why not bring it to you guys? So as I always say when I start these type of videos, it's time to learn something new. And in today's video, we're going to be going over Cisco ACL Lab that I created that is not too advanced, but it's good for beginners. If you're doing your CCNA studies, I think it's perfect for you right before the exam to go over some key topics that will definitely come up during your exam. And it's good to know, as I always try to use a real world scenario, or when using the type of technology that you're trying to learn in a typical way that will be used. So that way, when you're going through the lab, you have that experience. So when you're in working environment, it's similar as it can be to a working environment. That's what I try to do my labs. As always, you can find the lab in my description, and I will link it to my blog post where you can find the step-by-step and follow along. That way, if you need to, you can pause this video, but by all means, take your time, especially if you're learning. And if you want, try to do the steps before I do it. And if you see the way I have it done on my website, you'll see that I always leave uncovered the commands that you have to put in, right? Because I want you to be able to try to figure out, especially if you're preparing for the Cisco CCNA, you want to be able to know those commands on your own. So I want to give you that opportunity, so that way you're not just reading a script. You're reading a script, but there's breaks that shows the commands covered, right? So without further ado, let's just go straight into it. Let's not diddle out anymore. And so the first thing we're going to have to do, as any lab, is turn on all our equipment, and I am using EVNG. It's my preferred. So while we wait, I'm going to turn on all the devices. In this lab, we're running through the process. It's setting up a small network, and we will use this network to show the different types of ACLs, specifically a standard name ACL and also an extended ACL. The standard name ACL is going to permit our NAT traffic, which is NAT overload, also known as PAT. Okay, it's definitely a concept you need to know if you're going for your CCNA and if you go into the real world, with this knowledge to get a job, right? So primarily that's what it's for, right? We're trying to prepare ourselves for a job, right? If you're going for CCNA, that's what you're trying to do. So now that we got that done, I'm pretty sure that the router has done its full. The first task of this lab is changing the host name of router 1. We're going to need to access the router and change the host name to router 1. Configure the router to use its Google's Dns Ip 8.8.8.8. Okay, so as always, we bring up the system. Since it's in initial configuration, we don't want the initial configuration. Let me center this a little bit more. Okay, not only did I center it, I also wanted to make it a little bit bigger for you guys to be able to see. Okay, let's bring this all the way up, or clear out that screen. Okay, so the first thing, as we always do when we're coming up with the system, is we need to enable the system, right? And once we're in privileged exec mode, we got to go into global configuration mode, which we do that by doing configure terminal or config T if you're doing shorthand. Okay, so to obviously rename that, it's pretty simple. We just do host name and it's router -1, right? Okay, the second indicates to do configure the router to use Google's DNS IP, which is 8.8.8. So we need to do first thing is allow to do domain lookup, although by default it's quite possibly that's already on the running configuration. So you may not need to do that specific command, but we will need to do this command, which is IP name -server and type 8.8.8.8. That is to indicate to your router that it's going to use DNS Server IP address 8.8.8. All right, so now that we've done that, that is the first task. Pretty easy tasks, right? Okay, configure router 1 interfaces. So configure each interface around as they appear in the table above. So if you are doing my lab, you'll see the table here. I have it also here, so I'm just going to keep that visible. Yeah, I can see that one, right? Okay, so for router 1, the first thing we want to do is we're going to go into gigabit 0/0. And this is our interface to its outside connection, which is supposed to simulate our ISP, right? So that one is pretty simple. It's going to be a dynamic IP address. So we're not doing static. That's pretty easy what we need to do, which is IP address Dhcp. Now we're telling the interface is going to look for a Dhcp. Now it's connected to a router that will provide that Dhcp IP address. I mean that dynamic IP address, sorry. So now that it's doing that, we're going to allow it to do its thing. Got to make sure you do a no shutdown, obviously, to bring up the interface. And now that I've done that, it should be doing a request for the IP address. And it did. As you can see, there's this log message which indicates DHCP 6 address assigned, interface gigabit 0/0 assigned DHCP address 172.29.129.216. And it is a /24 subnet, right? So good. Now we've done 0/0, we can move on to the next interface, which is interface 01. Interface 01 is our LAN. It's our LAN interface, so we need to make sure we do that. So now that we're in interface 01, we're going to assign the IP address that is listed there, which is 192.168.5.1, and this is a /24, so that's 255.255.255.0, right? And as always, got to make sure we do a no shut on that interface, right? Okay, good. All right, so that is the gateway for our LAN interface. And we have a third connection, which if you see in the lab is for our connection to our web server. All right, so we're going to interface gigabit 0/2. And the IP address assignment for that one is IP address 10.200.1.1, and it is going to be a /28, which is 255.255.255.240. All right, and as always, do a no shutdown to bring up that port. Good. It's always good that we verify our work, right? So I'm just going to exit out of the interface configuration mode and back into global config mode, and to verify, instead of just ending the session in global config, since I still got to do my configs, I'm just going to do a do command. So do show IP interface brief. We want to see that all our interfaces that we have entered have an IP address, which is obviously our 0/0, which is our DHCP, our dynamic IP assignment, and then our two static interfaces, which are for the LAN connection and our web server connection. All right, moving on to the next step. And I forgot to show, but obviously, again, as I was indicating, if you're following along, you can bring up in the description, you'll see the link to my blog post. And as always, if you want to corroborate your work, make sure it's done right, you can always hit that show, and it'll show you what you're supposed to do, right? And that is what we did for both of them. Okay, so now the next task is create a DHCP router on router 1 and name it Workstation LAN. Okay, so we're going to set up a DHCP pool named Workstation LAN, set the network as 192.168.5.0/24, configure the DNS server to use the Google's DNS Server IP address. So in our network, we're not housing our own DNS IP, our DNS server, sorry. We're going to be using an external, which is Google's. Or in most cases, you would probably use your ISP or a specific one that you have created in your corporation's network, right? So the task also requires us to set the gateway as the IP assigned to interface G0/1, which is basically saying we're going to use that gateway IP, that interface 0 GI0/1 as the interface out for the network that we're creating for the Dhcp pool. And we're going to reserve the first 25 IPs and the last 55 IPs. Okay, so those are a few tasks that we'll have to do, and we're going to break it down in a few steps, right? Set up a Dhcp pool. So set up a Dhcp pool is pretty darn easy. All we got to do is IP Dhcp pool workstation-LAN is the name of it, right? When in doubt, question or tab it out, right? So okay, now we created that pool, but now we got to do the actual work, which is first assigning that network. So we're going to do 192.168.168.5.0. I believe you can use the Saturn notation, or you can do the subnet mask. Either way should work, but if you don't believe me, we'll do a space and do a question mark, and as I had indicated, you can do the Saturn notation, which is shown here with the /NN, or we can do the actual network mask, whatever's your preference. I'm just going to do the network mask, but you could have done /24 and it would have worked, right? Okay, so the next part of that task says configure the DNS server to use Google's DNS Server IP address. All right, so that one's pretty easy, but before doing that, I think I should have put the step first, the gateway. So to do the gateway is default -router, and we're going to put the interface IP address, which is 192.168.5.1. So that's going to indicate any system that connects on that network that they need to create the gateway to be 192.168.5.1, right? Okay. Besides that, we need to do Google's DNS Server IP address, which I believe is just IP DNS. No, it is DNS Server. That's what it is. DNS Server 8.8.8.8. Right? And then we're going to reserve the first 25 IPs and last 55 IPs. So we actually don't do this in the DHCP configuration. We're going to exit and go back to the global configuration. This is where you're going to set up the excluded IP addresses. So we do that by doing IP DHCP excluded address, excluded, if I know how to spell, excluded address. And we're going to do, it's going to require to do the low. And if you don't believe me, you do a question mark, you'll see it. It's going to require to put the low. So we want to reserve 192.168.5.1, which is the gateway. And it says the first 25. So 192.168.5.25. But there's also a second caveat. It says the last 55 IPs. So this is a /24. That's a full 256. So the last 55 should be IP DHCP excluded address, do 192.168.5.201, and it's going to go all the way to 192.168.5.255. We want basically the last IPs of that. Typically, you don't want to use all your IP addresses of subnet, right? So you would technically usually have some IPs that need to be reserved. in any network, right? And there's multiple reasons why you would have reserved IPs, but usually it's because you need to have certain users with a certain IP, maybe, or certain devices with certain IPs. Whether if we're talking about printers, for example, that could be a good example where you want specific printers to use specific specific IP addresses, and maybe the rest you don't care so much about, right? Things like that. So there'll be different reasons why you would need to do that, but we completed all the task of that, which is basically we created the Dhcp pool. We called it workstation LAN. We set the network boundaries, which is 192.168.5.0, and do /24 or put the subnet mask. We indicated that the default router for this Dhcp pool is going to be the 192.168.5.1, and then we indicated the DNS server. So in order to verify that we did our work correctly, let's do a do show, and we can do a do show run pipe section Dhcp. All right, so then I have all the commands here, and I can verify here. Okay. Oh, there's a mistake here. I gotta erase one of those. I'll correct that in the before posting the video. But it's no biggie. It's just entering the command twice. It's not a big deal. But as you can see, that's basically what we did. Default router, DNS server, and voila. So we got all that. Now we're gonna set up PC1 to be a dynamic IP address. So I'm using EVNG's Docker servers for PC1 and the web server. When you are adding the node, I just want to show you guys this. Let me just, as if I was adding a new node. And if I were to just like Docker IO, the image would be the GUI server. You know, name it how you want to name it. If you want to follow along with me, it would be, you know, PC1, and use the desktop icon. The important thing that you need to do for PC1 is make sure that this is checked, which says enable Dhcp on Ethernet 0. Okay, I already did that, so I don't need to worry about that. But make sure you do that, because if not, it's not going to pull the IP address dynamically. If you didn't use the Docker image, because you're using, I guess, the community EVNG, which, you know, if you're, you know, starting off, you may not have purchased the pro license like I have. You could, I think with the community, you still have like VMs. Make sure that you have it set to, you know, to be dynamic. It may not be there specifically. You might actually have to configure in the server itself, but, you know, make sure it pulls a dynamic IP. If all else fails, you know, and you can't set up a dynamic IP address, then I guess you can configure. But if it's going to be configured, I guess you should be using a reserve IP that is not obviously the gateway IP address. So if you were to do it static, if you're going to follow the directions, right? But I just wanted to show you guys that in case, you know, you're following exactly how I did it. So that's how I did it. So it's able to pull a dynamic IP. All right. And we can verify that it did pull a dynamic IP by just, you know, accessing the server, which we're going to do right now. Make it a little bigger so you guys can see. System tools, and we just go to the terminal. And to keep it simple, I'll just do if config, and then obviously Ethernet 0. Did I take too long to, I may have. Because I don't think they excluded, yeah, that's what it is. I didn't take into account that I brought the system up, and when I did the lab, I made sure to turn on the system afterwards, but it's no biggie. It did pull a dynamic, and then we since I took too long to do the dynamic. So what I was trying to say is that I probably should have not turned on this before doing the Dhcp pool, but since I was creating the Dhcp pool and took a while to exclude the IP address, maybe that is why it got .2 instead of .26, which is what I wanted it to get. But it's fine. We'll deal with that. It's not a big deal. Okay. You get the idea. We were trying to create dynamic IP. It did end up getting dynamic IP. You just didn't get in the range that I wanted to. But it still works, right? And we're in a lab environment, so things sometimes don't work how you want it, and that's why we lab, right? To learn. Okay. So now setting up the web server as a static IP. This one I want a specific IP address, right? Because your servers, you're more than likely are going to have them set up with a certain IP address. You want them specifically to use, the same IP address over and over again, because they're going to be used by multiple resources, right? You get multiple users from multiple resources. So it makes sense to have a reserved IP. So in most networks where they have servers, you're going to be using a reserved IP, right? Okay, so this one indicates that we're going to reserve the IP. Assign the IP, which is 10.200.1.4, right? And again, I use the Docker image, but if you have a VM, you can, any type of Linux VM, similar commands should work. And I like to do it in the terminal, because if you're doing it in Linux, you might as well do stuff in the terminal. And besides, if you're studying for Cisco, CCNA, you shouldn't be afraid of terminal access anyways, right? Okay, so to assign the IP on a Linux device is pretty easy. I'm in root, so if you're not in root, if you're just a regular user, you should remember to do sudo. But I'm in root already, so it's just IP addr add, and we want the IP address, which is 10.200.1.4/28 is the subnet CIDR notation, and we want to indicate that to use Ethernet 0 as the interface where we're going to assign that IP, right? And then after that, we want to assign the gateway, so we're going to be doing that by doing IP route add default via 10.200.1.1, which is the network interface that we created on the router, which is GI02, right? Okay, now that we have signed that, I want to first and foremost do a ping to its gateway. So I want to make, that's not its gateway. Make sure that we can get to this gateway, which we can. And we should be able to also hit the other gateway, which is 5.1. Make sure I do ping and before the 5.1. All right, that works. Okay, so the web server and the PC1 are both up and running. I should be able to actually ping PC1, which I'm going to do right now, 5.2. But if you didn't turn on the PC like I did beforehand, you may have it .26, which is what I wanted to do. But here, there. Okay, so they're communicating across the board, right? And that's what we want. Well, one thing we wanted to do, and you'll see this next, which is configure NAT overload. NAT overload is what it's going to permit us to use one IP address and overload it with all our internal IPs using the port numbers in order to exit out to the internet. Most homes, that's how you have it, right? You have your router, which does NAT overload, and you have one publicly accessible IP that is provided to you by the ISP. Most of the time you have your router set to DHCP. Okay, so we're going to define. So our next task asks us to configure NAT overload path on router 1. So the first thing we're going to have to do is define the NAT inside and outside interfaces. All right, so the first thing we need to do, since we've been offline for a little bit, is re-enable it and get it back into global configuration. So we do that by doing configure terminal. All right, I'm in configure terminal. So we need to define the NAT outside interface and the NAT inside interfaces. All we are requesting for this lab is our LAN to be the internal network and overload, right? So our outside interface is going to be GI00, and our inside NAT interface is going to be GI00/1. So our LAN is the inside, right? And our outside is our connection to the internet, right? So that's how it's an easy way to remember that. So I'm going to first go into the outside interface and do IP NAT outside. Just doing its work. Okay. Then we're going to do interface GI0/1, which is, this is our LAN network. So IP NAT inside. Voila, that's pretty easy. So that's the first step. Okay. Our next step is creating a named ACL using the name NAT-ACL permit the workstation LAN, which are all your devices on the 192.168.5 network, on the ACL. So we're going to do that pretty easy. All right, we're going to bring up the router. Let's go back into global configuration mode. And we're going to do IP access list. And this is a standard access list because that's what the task requires, that we do a standard named ACL. This is where it's going to be different. So normally you would put, if you see here, question mark for standard, you either do 1 through 99 or 1300 through 1999 for your access list. But we're doing a named access list, which is just entering the name, and it requests it to be called NAT-ACL. So for the most part, if you're doing for NAT overload, I would actually usually use a named ACL. It's just easier, so that way you know, okay, it's that a specific ACL is for the NATing, and not necessarily a number one. All right, so it says to permit, right, the workstation LAN on the ACL. So that one's pretty easy. All we have to do is type permit to permit the traffic, and then we want the 192.168.5.0, but we want the whole network, so it's going to be 0.0.0.255. This is a wildcard mask. The wildcard mask is the subnet mask, but in reverse. So all your ones become zeros and all your zeros become ones. So in the subnet mask 255.255.255.0, you have 24 consecutive ones turned on, and then the last 8 bits of that 32-bit space are turned off, right? So the wildcard mask is in reverse. So all those ones that you have turned on will be 0. So the first 24 will be 0. And then the last remaining 8 bits, which were turned off with the subnet mask, in the wildcard mask, you're going to turn it on. So that's why it's 0.0.0.255. Okay? So that indicates the limitation it has. All right. Moving right along. So now that we have created that, set the ACL NAT ACL as the inside source and set the outside interface to overload. Real easy. We're going to exit out of that ACL, go back into global configuration. And we're going to type IP NAT inside source. It's going to require the list. So list, right? And it's going to require the list. And I was about to type it named ACL. NAT ACL is the name, right? When in doubt, question it, right? And then we're going to indicate the interface. Whoa. Sorry, the interface, and we want gigabit 0/0, and we're going to overload that port. So we're overloading the outside port. Okay, and it says it right there, set the outside interface to overload. So we're basically saying, okay, create a NAT role, and your inside source is going to be provided through the ACL. So the ACL is not acting as a it's not acting as a way to block traffic. It's actually filtering the traffic, because we're filtering the LAN traffic that is on the router. That's what we want to use this ACL to exit out. Okay, and we indicate to overload the outside interface, right? Because when it exits out, when we do that NAT overload, we're actually telling the router to assign every session that's leaving a port number, so that way when it returns back, it's going to have the source IP being the accessible IP address that is on that router, right? Which in this case, if we do show IP interface brief, I can show you. Gotta remember to do. It is that 172.29.129.216. That is the accessible, publicly accessible IP address. And I say publicly accessible because that's definitely not a publicly accessible IP. What is the IP address that our ISP has given us, right? So when it comes back, it's going to have that port number. And that port number, you know, when it comes back, that traffic is going to be assigned to a IP address that's internal inside the network. And that's how it's going to know, oh, okay, this is for the traffic that is inside the network. So I need to exchange it, or not change it, you know, through the table that I have. That's what the router is going to do. And it's going to give it the internal IP address as the final destination IP once that packet hits that router. Okay, so that's why we overload that outside interface. Okay, all right, now that I've done that, we should have all the necessary bits that will provide internet traffic to our PC1. So I'm on PC1 right now. Okay, we can reach the gateway. Let's try to ping 8.8.8.8. Oh, maybe it was up. I checked the wrong thing. Let's do CNN.com. I like to use a news website in order to make sure that I actually have internet connectivity. It's not cached, but obviously this is a container, so nothing's cached. All right, so that's definitely definitely internet access. PC1 now has internet access, right? So we're good. So we verify internet connectivity for PC1, and now I also want to do something else. So again, if you use the Docker container like I did, you will already have this part done, so you won't have to do this. But you might have to, so I'm going to show it. So we're going to access our web server's IP, which is 10.200.1.4. So obviously PC1 and 200 and the web server were talking with each other. Now on the web server with the Docker, it already has Apache up and running, so it's good, you know, for testing. So Apache is already running on port 80. How do I know it's port 80? Well, the default port for internet web traffic is HTTP, and this is definitely an HTTP. So it's port 80, right? Okay, good. But in case you're using a Linux server and you don't have Apache installed automatically like I do, because I'm using a container, then you should be able to do these commands, which are sudo apt update and sudo apt install Apache 2. And this is for, obviously, because it's apt for Debian based Linux servers. But if you are using Red Hat, it would be Yum, I believe, or I don't remember what's the newer one that Fedora uses. Maybe it's DNC, I could be wrong. Or if you're using an Arch distribution, then it would be, was it Pacman or Manpack? One of those. But similar, you would just do install Apache 2, which is a web server, and once you have that, you should be able to pull just by using the IP address on PC1 of the web server IP, pull the auto created website that Apache does. All right, so this is just specifically done for the lab. I show you that just in case you need to, and it's there if you need it. But if not, just look up how to install Apache if you're using a different distribution. If you're using a Windows VM, I guess you could install Apache too. I don't have the steps on how to do that, but I'm pretty sure it's not too hard. Anyways, we just want to make sure that a web server is running so that we can, do the next part, which is we want to block some of our traffic. Okay. The next thing I want to do on my web server, after already doing that for port 80, is starting a Python script to create a simple HTTP server, which if you haven't done this before, it's good to know. It's one of those cool things to have in your pocketbook of wonders, or your tricks, or whatever you want to call it. Okay, so this is good to use. So we want to use Python command here. So it's going to be Python-m. You obviously will need Python installed if you're going to be doing this. HTTP server, and we're going to open this simple HTTP server on port 8080. But to test that it is working properly, after it says serving HTTP on port 8080, we'll go back to PC1, and now do HTTP 10.200.1.4, but we're going to add the colon and do 8080, which is the port number that we want to access, and we'll see this, which is the directory, because when you do simple HTTP server, It creates wherever directory that you are currently in basically access as a web server. So this is good, like if you need to copy files, because you can basically put files right there and then download them. Obviously, don't keep it up. It's basically just to do what you need to do and then close it. All right, but we're doing this because we want to see different ports open on the server itself and be able to block certain traffic, right? And we're going to continue our lab. Okay, so once you have made sure that you have access to the internet and you have access to your web server on port 80, which is that default Apache 2 page that we saw, and also with the simple HTTP server on port 8080, we now have access to the simple HTTP server app, which is showing the contents of the current directory that terminal session is currently on, right? Now we can go on to do the next step, which is creating an ACL, but we want to block PC1 to port 80, but we also want to continue to permit the traffic to port 8080. And this could happen for multiple reasons. Maybe you have certain users that don't need access to certain servers or certain management interfaces, because sometimes a lot of your web servers could have multiple interfaces. Could have the regular user interface for the general public to visit, but it also may have a certain port, a hidden port for your management access, and you don't want everyone to be able to access that. So you want to specifically block the personnel from viewing it. So we'll go back into our router and move into global configuration mode, right? And in order to block it, we're going to create, and as it says here, create an extended ACL using the access list number 104. Assign the ACL to the appropriate interface, and remember that the ACL created should be configured closer to the source. Right, that's a key thing about ACLs. You always want it to be closer to the source. And why is that? Let me just show you. It doesn't make sense, right, that we force the traffic to go all the way through the router, then after the router, go through this way to the server. We want to stop it closer to the source. So that way it hits our router, which is where the ACL is going to be, and then we're going to stop it. So if we want it closer, we want it stopped at G0/1. Now, here's the next part. We don't want it to go to the web server, then come back, then block it, because that'd be stupid. You'd be making your router do more work, right? So when you block it, you're going to want to block it as it comes in. Keyword there, as it comes into the router, right? So I say that, and as I write the ACL, I'm going to show you why I meant the in part. Because when we assign it to the interface, we're going to indicate that ACL is going to be blocked. I mean, it's going to be used when the traffic comes into the port. So that means in to the port and not out. If we did out, that traffic would actually go all the way to its destination, then come back, and then it would be blocked, which we don't want to do, right? We want to block it closer to the source. We want to block it before it has to do all that extra work. Why would we want to use up our network resources when we know that that traffic should be stopped beforehand? So that's why when we create the ACL, we want to do it in, with the traffic coming in, okay? I say that, and as I am doing it, you'll see what I mean, okay? So again, from global configuration mode, we're going to do IP access list, and it's an extended access list, and we indicated it's going to be using access list port number access list number 104. Okay, we want to permit 8080, but block port 80, right? So we can do it either way. We can do the deny first, or do the permit and then do the deny first. Remember, there's also an implicit deny, and that will come up in later. But we want to make sure we block port 80 specifically. So since that is specific, I would do the deny first. So deny TCP, because it's going to be a TCP port on the host. We're going to deny 192.168.5.2, which is PC1's IP address, right? And we're going to deny it to the host 10.200.1.4, which is the web server's IP. And it's going to be equal to port 80. Okay, so any TCP port from PC1 to 200.1.4, which is a web server, we're going to block it if it's using port 80. But we need to make sure that if we block it, we need to permit the other traffic. So we do want them to have access to port 8080. So we're going to be doing a permit rule, which is permit TCP, and then the same host is the source, which is 5.2, which is PC1, and then the destination is that web server 1.4, and then it's going to be equal to port 8080. All right, so we are denying that HTTP traffic, but permitting 8080. All right, we're going to exit out of the configuration, ACL configuration mode, and we're going to go into the interface. Okay, the interface that we're going to be doing this on is obviously, because I said it's closest to the source, so its gateway is G0/1, that's closest to the source on the router, right? So interface GI0/1, and to assign, no, not, what are you doing? So assign an IP access list is IP access group, not access list. When you actually do the ACL assignment on the interface, it's going to be access group. And then usually you would put the number, but this is going to be the name. So the name is the number, actually, because this is our extended. I almost did a boo-boo there. The number is 104, which is our extended ACL that we created, right? So IP access group 104. And where do we want it configured? I said earlier we want it configured in the in source, so that way when the traffic is coming in to that router, it gets blocked. We don't want the traffic. I mean, it will work if you do out, because it, hit the web server will respond back. And then as it's coming out of that interface to the PC1, then it'll block it. But we don't want that. We want it to do it beforehand, because we don't want our router to have to do extra work it doesn't need to do, especially since our router is already going to be doing extra work doing NAT overload, right? So that's why we're going to set it to IP access group 104 in and not out. Okay. Now that I have assigned that ACL to that interface, we need to be able to verify that PC1 no longer has access to port 80, which is this page. Voila. But it should still have access to this guy, which it does. But what do we do wrong, right? What do we do wrong at this point? Now we've blocked internet access to PC1, and that is a unexpected result for our ACL. Or I kind of knew what was going on, obviously, but this happens. You may implement an ACL and you block certain traffic for certain people. And when you create an ACL and you get a trouble ticket coming in from help desk saying, hey, this person no longer has internet access. So if it's someone important in the company, good job. You just pissed off that person. And if they find out that you did it, they're going to be very angry. So make sure you fix it quickly. So what do we need to do in order to let now this user have access to the internet again? And I'm going to show you. I'm going to hit Google. It's going to be blocked. We need to permit the traffic. Remember, there's a implicit deny at the end of all ACLs. That implicit deny. So there's that permit rule, which is permitting that traffic. But that implicit deny at the end of the ACL is going to block that traffic. So we need to make sure that we allow it. So what we need to do is basically go back into the access list, which is IP access list, and just so it took a while, but yeah, surely but surely it got blocked. This user no longer has access to the internet, and we need to fix that. And not only him, everyone on that network right now has no access. So you got a lot of people calling help desk, not happy, right? So IP access list extended 104. So we go back into the access list. What we want to do is add a permit rule before that implicit deny. If you do a do show run section 104, let's do, if I type section right, you can see the rule, right? We want to make sure we add the permit rule. So what do we do to permit the traffic? We want to permit the rest of the traffic. So we're going to do permit IP any, so it's any host and any destination, and for all the ports. So that's why we did permit IP. So any host as the source and any destination. And that way, any new rule that needs to be added to that ACL, we should do it in front of that permit IP and any, because it's going to allow the rest of the traffic. Now that I've done that, our users should now have access to the internet. And as you can see, they do have access to Google now, and news.google.com for your news. Okay, so that's basically it. That's it. This was the lab. All right, and if we go over again everything that we covered, we created a named ACL to permit the NAT overload, and we also created an extended ACL to block certain traffic, because it could happen that you need to block certain personnel to certain devices on your network, and we do that with an extended is probably better, because there you can specify specific ports, right? With the standard, you're not really specifying ports, you're just doing the whole IP, which is not the best case scenario for this. And in normal, this is a normal way of blocking traffic, but it's not the best way, obviously, to block traffic. If we're doing security at a real network, probably that web server would also have a firewall, a host firewall on it to block specific users as well, right? But security is done in layers, right? So our first layer for our network engineers and our network admins are ACLs, right? So with that being said, it's a way to block the traffic to certain devices that you may need to do, and that's why it's important to know ACLs. And it's important because you've got to know it for your CCNA anyways. Okay? So with that being said, I hope you guys enjoyed this video, and if you did, make sure you hit that like button and you comment down below anything I may have missed or anything advice you want to give me, or just to any questions you may have had as I went through the lab. Anything you want me to explain a little bit better in detail, I can. Just write it down in the comment down below. If you have not subscribed, make sure you do subscribe. And you click on the bell notification, set it to all. That way you'll be notified first whenever I upload a video. Now, my channel is evolving. I am doing gameplays because I enjoy to do gameplays, but I also want to do more of these videos. So if you do like it, make sure you let me know specifically this is the type of videos you want to see. And I obviously have different playlists. This one will be under our Cisco playlist where you can access it. And obviously in the description, you'll find the link to my blog post where you can find this exact project. And this exact lab and other labs if you want to on my website. Okay, and there's no advertisements on that website. I specifically did that because it's not supposed to be a way to earn money. It's supposed to be a way to present as a portfolio of what I want to do, and what I want to do is basically teach network engineering. So there you go. It's free stuff for now. No advertisement, no nothing on my website. It's just for you guys to visit. So since I'm not getting any money off of that, make sure you hit that like button, comment down below. It helps with the YouTube algorithm to make it be known and be shown to more people, okay? So as I always say, until next time, peace.